everyone, and welcome to the second installment of the Webisode series brought to you by Mr. Petrella. This is Mr. Petrella speaking. In this second installment, we're going to focus on the key student challenges or misconceptions about fractions and some of the more prominent problems for fractions of intermediate learners, especially focusing on grade 7 and 8 students. Now we're going to highlight 3 specific problems today. However, you can extrapolate, and I'm sure you'll find that there's many of your own problems that may need to be solved. Now the ultimate goal from this webisode is not solely to answer these 3 questions, but rather to give teachers the advice and to give teachers the resources that they can use to help students learn and create connections for these problems that they may encounter, especially specifically regarding fractions. Now, as we take a look at our first example here, it states students should be able to add and subtract fractions with unlike denominators. Now, this is a specific curriculum expectation. However, students oftentimes have problems when it comes to adding and subtracting. They don't know when to find the common denominator, or they get confused between finding the common denominator through multiplication. Do I need to find it through multiplication, or do I need to find it through subtraction or addition? Now again, this is a simple misconception that can be modified with the correct teaching and the correct exploration from the student. Now when we take a look at the second example here, it's another common misconception for students. They have trouble with the idea of multiplying whole numbers versus the idea of multiplying fractions. Now again, as a teacher, you want the student to really connect or analyze and explore this idea and connect it to one of those bigger ideas that we talked about in the first module. But as students see it, 2 times 2 creates a bigger number, which is 4. Now, consequently, if you multiply 2 fractions together, for example, 1/2 times 1/2, you're going to get 1/4, which is a smaller number. And this is, again, a very hard concept for a lot of students to understand. Usually when you multiply 2 numbers together, you get a bigger number. Now, as you can see, I'm providing an example of a solution here to explain how to multiply 2 fractions together. I've just chosen a simple example like 1/4 times 1/3. A lot of students also really struggle in identifying the picture form or some type of graphic form to show the multiplication of fractions. Now what I've done here is I've drawn a whole and I've divided it into 3 different parts. I've shaded in one of the 3 parts, which denotes the 1/3 in the question. Now we still have to multiply it by 1/4. Now in order to multiply it by 1/4, we have to divide that whole again into 4 separate sections. And as you'll see, I will color in one of the 4 sections as well. Now, as teachers, the goal here is to try and get students to understand this concept and be able to produce these results themselves. Now, as you can see, I'm writing here, where do the 2 sections intersect? And that's going to be our answer. Now, we can kind of, as teachers, see that and picture that because we have a good understanding of mathematical knowledge. But the goal is to get students to also understand that mathematical knowledge to be able to solve this question and many other questions similar to this with relative ease. Now, our last common misconception or challenge to a lot of students at the intermediate level involves multiplying a fraction by a whole number. And this really can be a simple fix if students are given the time and the appropriate resources and manipulatives to be able to discover and explore this connection between fractions and whole numbers by themselves or in small groups. And that's what's really important here. But students really struggle with the idea that 3 as a whole number can be expressed as 3/1 itself, and you can simply multiply the 2 numbers together. So the question then becomes, how do we fix these problems? We don't want to solve just these discrete questions that these students have, but rather instead we want to get them to those higher levels of Bloom's taxonomy. We want students to synthesize, to evaluate, and to analyze the information that's given to them rather than just answering these small, discrete questions. Now, it's an entire philosophical change that has to happen. There's a newfound emphasis placed on problem-based learning, and it's an effective three-part lesson technique that allows students to turn their minds on, to actually practice the examples, these whole-bodied examples, and then lastly finishing with the consolidation of knowledge. And you can get an excellent resource here by clicking the link above, Engaging Students in Mathematics. It has an excellent example of that problem-based learning. The second article there deals with conceptual versus procedural knowledge. Now, procedural knowledge is many times what we're teaching. 1 times 1 is 1 and 2 times 2 is 2. However, what we're trying to strive or drive towards as teachers is to help students have a conceptual understanding of why these procedures are the way they are. Why are these algorithms the way they are? There's something that's meant to process there. So please take a minute and click either of the links you can see there on the page, and you can read 2 excellent articles by 2 great authors about this problem-based learning as well as conceptual versus procedural knowledge. Please join me for our 3rd module, where we'll be talking about some other professional resources, including teacher supports, student supports, and parent supports. Thank you very much for your time.